See Lindelof videos, inverse trig function sine. So start with this stupid definition which says that y is equal to the inverse. This is not an exponential power. This is actually symbolic. And this is read inverse sine of x, or the inverse of sine of x. If and only if, that's the IFF, if x is equal to sine of x. And this is what this says. It's relatively simple. It says this. Usually when we talk about sine, we ask for sine theta. And when we get back sine of theta is some, right? We get back sine of theta, and it's some number between -1 and 1, isn't it? So if I take sine of pi fourths, then what I do is I go to the unit circle, right? I go to pi fourths. Here's the sine value right here, isn't it? Here's the pi fourths. Here's the sine value right here, right? So I go back, and I say that is equal to the square root of 2 over 2, right? And therefore, if I was going to graph this, point on the sine curve, I would say it is the point. Remember, in our case, it's the point angle, then sine of that angle, isn't it? So we'd say, okay, it would be the point pi fourths, sine of pi fourths, and sine of pi fourths, we just found out by looking at the unit circle, is equal to the square root of 2 over 2. Everybody all right with that? But remember, when you take the inverse of a function, you switch the domain and range. You switch the x and y values. So instead of saying, what's the ratio that corresponds to this angle, what you're saying in this case, you're saying you're taking inverse sine of something. What you're going to get here is you're going to get some value that's between -1 and 1. Let's say that I take square root 2 over 2. And then what you're going to do is you're going to ask the question, not what ratio goes to this angle, but what angle goes with this ratio. Does that make any sense? So what's really important is this, and I'll show you why this is true. What's essential for us to start with is this idea right here, that our angle has to be between pi halves, negative pi halves, and pi halves. So when I look at it over here, when I look at this over here, the only place, given sine, the only place I'm going to look is here. Right? So let's try one. Let's do it backwards and then forwards. So if sine of pi fourths is equal to square root 2 over 2, then what's inverse sine of square root 2 over 2? Pi fourths, right? Because in the case of the inverse, we're looking for the angle that fits the ratio. So what am I going to do? If this was the question that I had, I would take this question. I would go to my unit circle, only looking at this part right here, and I'd look at all the sine values. I say, okay, I'm looking for square root 2 over 2. This is not square root 2 over 2. This is not square root 2. This is opposite square root 2 over 2, so that's not it, is it? And I would keep looking until I found that ratio. And here's that ratio right here. So I'm like, okay, I found it. What does it correspond to? Well, it corresponds to the angle pi fourths. Do you see how we're doing it backwards? Before, we would go to pi, we would go to the angle, and then we'd look for the sine value. Now we're doing it the other way. We're saying, let's go to the sine value and see what angle corresponds to it. Does that make any sense? So when we go back this, let's try another one. So how about this? Sine of pi thirds. Sine of pi thirds. So on your unit circle, what's sine of pi thirds? So it's square root 3 over 2. Does that make, so that's true? If that's true, then we can use the inverse. The inverse will be just this rewritten, won't it? Here we're saying, if I have the angle pi thirds, what's its sine value? So if we looked at it differently, we could say this. We could say, what if I have the inverse sine of square root 3 over 2? What should that value, what's the angular value that goes with this sine value? Should be pi thirds. We can go check. Go check by going here. Remember, we're going to stay from, right, we're looking at this as if we move this way. So this is negative pi halves, isn't it? This is pi halves up here. So we're going to go from here to here and look for it. And the value that we were looking for was, the sine value was this, isn't it? And what angular value does that correspond to? Pi thirds. So you go back, and Nicole, you're right. Does that make any sense at all? Here's the thing that you have to keep in mind, that the angular value has got to be between negative pi halves and pi halves. If you go beyond that, you're going to get more than one solution. You're going to be like, which one is it? So we're only looking in that part of the circle that you have highlighted. All right?